Hello, welcome to Tech Talk with Steve, episode 28. Today we're talking about DC resistance measurement versus PoE testing. What's the difference and why are they both important? So we hear a lot out there about power over Ethernet. We're in an era now where just about every commercial building is really a smart building. So we're seeing all kinds of things deployed in the buildings. We're seeing monitors and window shades and phones and all kinds of devices that are powered by PoE, rather than conventional power methods. So we need to address, when we install the cabling, is it going to be ready for PoE? And then also proof that cabling to make sure that we actually can get the power at the endpoint. So there's a lot of things going on there. You may hear, we're going to talk in depth about resistance testing. We're going to talk in depth about actual PoE testing. You may hear some refer to a certain type of DC resistance test as a PoE test, but it's not really a PoE test. It's more of a pre-qualifier, and we'll dive into that as we go along here. So I am going to go ahead and share my screen. And we'll get to the live tester in a moment. I'm going to talk about a few things. I've got a few slides here that we can use today, and we'll just kind of dive right in. So that, the conventional testing needs that we think about when we're dealing with our commercial building cabling infrastructure, fall under this first column here. Your typical parameters when you're certifying: length, delay, your DC loop resistance, which is the resistance, round trip on that pair, insertion loss, return loss, crosstalk, all these parameters. We're used to seeing these when we're talking about certification. So there are some optional parameters that are not required for certification, but they are pre-qualifiers for power over Ethernet. So it assesses the cabling and it determines, will this cabling actually support PoE? This is useful not just for a new installation, but maybe you've got something you installed a year or two ago and you're getting ready to run PoE over it, and you want to find out, will it support PoE? You can go back and run this test with the optional plus parameters engaged as pass fail, and determine if that cable should support the PoE that you're about to deploy. So it's an important measurement. And what this plus parameter adds, in addition to the DC loop resistance, it adds two other DC resistance parameters. It adds the unbalance in pair. So what it does is it looks at each of the conductors within a pair, and it's going to compare the resistance value for each of those conductors and make sure that they're within a certain tolerance. And we'll talk about these tolerances here in a moment. And then it does the DC resistance unbalance pair to pair. So it'll look at each pair and compare it to every other pair. So you look at all the possible combinations between the different pairs to make sure that they are within the specified tolerances as well. Now that's on a permanent link. Now when you choose the plus parameter on a channel, what happens there is, in addition to those DC resistance unbalance issues, we add something called TCL and ELTCTL. And essentially, just to boil that down, those are tests that determine the noise immunity level of your cable. So as long as you pass those tests, you can be assured that you have the noise resistance that you need. So you're not going to have undue impacts of noise on the cable. And again, all of these are pre-qualifications for power over Ethernet, because the noise is going to affect how the Ethernet performs. It's going to affect the PoE, those kind of things. Those are the parameters, the plus or plus parameters that we're talking about. And we're going to dive deeper into this resistance parameter. Some additional parameters that your test equipment should have are troubleshooting functionality built in. TDRs, if it fails return loss and crosstalk, if there's a problem with the shield, you can actually do a TDR trace and pinpoint where along the length of the cable that issue is. And then the other testing we're going to talk about related to resistance measurement and comparing it, the differences between a resistance measurement and actual PoE testing, falls under the last column we see here. Now, the example you see here is a multi-gigabit test with PoE. We'll show that, but we're more importantly, we're going to talk about a troubleshooting PoE load test as well. So if you do have issues with PoE, you can actually do a PoE load test to make sure that you can get that power at that endpoint. And it can be incorporated into the auto test result that you see on the lower right of the screen there when you run a multi-gigabit test. So we'll start with resistance requirements. So, specified per the standards, the DC loop resistance, and we're all used to seeing this. It's been in our certification tests for some time. So you have a 25 ohm loop resistance. And what that means is that round trip on that pair of copper, each pair cannot exceed 25 ohms. So as long as it's below 25 ohms, it's considered a pass. The additional parameters that we just talked about, the unbalanced in pair and the unbalanced pair to pair, there are additional specifications. So less than 200 milliohms or less than 3% of unbalance within the pair. And then unbalanced between pairs, also less than 200 milliohms or 7% of unbalance between pairs. So it might be higher than 200 milliohms, but it's going to be falling under that 7% number there when you're comparing one pair to another. And again, as I mentioned before, these DC resistance unbalance tests are not a PoE test. If you hear them described as a PoE test, that's more of a marketing thing. They're not PoE tests. They are actually a pre-qualifier for PoE. And you can be fairly comfortable that if you pass those tests, you should be able to support PoE, but they aren't a true PoE test. So, and the good thing is on these parameters that I've laid out here, these specifications, you don't have to memorize these. The testers know all this stuff. So once you set the tester to pass fail, it's going to know it. So here's why resistance matters when it comes to power. And there's an equation at the bottom. We're not going to take a real deep dive, but I'll kind of give you in a nutshell what that is. But ideally, in a circuit, you would get the exact same power at the endpoint that you put in at your power source. But in the real world, that doesn't happen. And mainly it's because resistance, that energy is dissipated in the form of heating. And with this resistance, we would expect that at the endpoint, we're not going to get that full power that we've put in at the start point. And that's why when you see on a PoE test, an initial PoE discovery test, we'll look at this in a moment, you're going to see a value called allocated power when you first discover the PoE. And that allocated power on a 90 watt is going to show up as 71.3 watts. And that number is actually achieved using the I squared R power loss calculation. So to define that and break it down, I is your current, R is your resistance. So your current squared times your resistance is going to give you the power drop. And this number that we get when we see this 71.3, this is on a good working 100 meter length of cable, what we can expect to get at the endpoint with 90 watts. And it's achieved using this calculation with the measured current under load. The resistance is going to be 6.25 ohms. Now that's combined. Remember, we've got 25 ohms per pair. We've got 4 pairs. So when you combine that to use it for power, that is divided by 4. So it's essentially 6.25 ohms loop resistance for all 4 pairs combined. And when you do the math, it comes out to a 18.7 watt power loss, which gives us that 71.3 when we subtract it from the 90 watts. So that's how we get to that allocated power number. That's why that equation is important. In the real world, where this equation really becomes important is if that resistance increases. If you've got one pair that's got really high resistance, all of a sudden that multiplied number, that power loss starts to increase because it's multiplied by however much additional resistance you have. And that's why resistance is important, because it will reduce the power at the endpoint. So when we talk about doing the testing, we talk about the DC resistance test, and we're going to show you some live tests with this here momentarily. The reason it's important to measure this, if you test a normal Cat6a channel or Cat6a permanent link test, the cable might pass that. But it's good, the cable looks good, you've certified it, it's fine. But a cable that passes a regular Cat6a test may not pass the DC resistance unbalance and the in pair or pair to pair. So you could get a cable that passes a normal Cat6a test, but as soon as you use the additional parameters of DC resistance unbalance, it may not pass that test. And this can be caused by a variety of issues. In this case, it's a channel test. This could be caused by faulty patch cords. It could be the cabling itself, could be termination practice, and sometimes it's the cable itself. There's been quite a bit of chatter out there about copper clad aluminum or other type cables that are out there, or low end cables that have impurities in the copper, and those can lead to resistance issues as well and impact this test. So it's going to be important to run this test. If you know you're going to be using PoE, you want to pre-qualify that cable. But again, the resistance test is a pre-qualification. So it's going to tell you, yeah, I should be able to support my power over Ethernet. And if you're doing it at the permanent link, it would just be the plus. But you see here, we also have TCL on this channel because we have the plus plus. So that again is our noise test as well. So we're looking at, we're thinking about PoE, what we're going to be supporting. Again, here's that allocated power number that we talked about. This is achieved through that calculation, and this is the theoretical amount of power you should get at the endpoint based on a good working cable. So that's 100 meters of good working cable. I should be able to get 71.3 watts at the endpoint on a 90 watt PoE. And it's going to be different for each of these. So you'll notice, the advertised power is always going to be greater than what this theoretical number is. Now, when you put a load on it, that we're going to talk about PoE load testing here in a moment, if you've got a really short run, your actual measurement may, in fact, in some cases, be higher than that theoretical number that you're going to get at the endpoint, because if you've got a really short run of cable, there's a lot less resistance. So you can get more power than that 71.3. So it really is going to be dependent on the length of your cable. And while we're talking about length of cables, I mentioned before that DC resistance troubles can also be caused by patch cords. If you have a really short link, a really short permanent link, and it looks good, if you have patch cords that are not good, they're lower quality, they're cheap cables that maybe you had to pick up something quickly because you broke a cable or lost one or something, and you plug it in, the patch cable becomes a bigger factor on these shorter runs when it comes to DC resistance and DC resistance unbalance. Because think about it, if you have a 30-meter run and you've got a 10-meter patch cord, or combined 10 meters of patch cords, and they're both the same low quality, now the patch cords are 25% of that overall channel. They become a bigger factor in that resistance. So we need to consider that as well. Load testing, we're going to show you this live here in just a moment. So load testing is going to be different from a DC resistance test. What load testing does, and we see in the first screen here, we see our 71.3 watts of allocated power when we've connected. And then once we demand the load, when the tester acts like a PoE device and requests that load, we can measure the real power, what we can actually get at the endpoint. And that's going to be important because you've pre-tested the cable. It may have passed fine with your DC resistance unbalance test, but sometimes things happen in the field that can cause issues with your PoE. So it's always good to be able to have an additional test in your quiver to assure that that cabling is ready to support what your customer needs. So I'm going to pull my camera up here. And so this is my remote test pro unit here. We're gonna do a physical cable test. We're going to show you some differences between the regular test and a test with the DC resistance unbalance, and then we'll show you some PoE type testing to give us some comparisons. So what I've got here, again, this is my Test Pro remote that you see on camera here. The display you see on the left side of the screen is my Test Pro. Now you will see a little bit of delay in this screen refresh on the one that's being displayed on my computer because I'm using something called VNC, Virtual Network Computing, and it's just a connection to my laptop from the Test Pro. It doesn't refresh as quickly as the live Test Pro does. So I'm going to go ahead and plug in, and as soon as I plug into my link here from each of my units, I will see a wire map on both ends. So, and again, you saw how slowly that painted. That's the VNC. You notice that the remote unit here came up right away, which is the way they do in the field typically. So we've got a wire map at both ends. In this case, we're going to do a physical cable test. So we know the wire map is good, and we can go ahead and run an auto test. So I'm just going to go ahead and hit auto test here. And the auto test will give us a result in 6 seconds. And at the end of that 6 seconds, we see this passed. We've got our Cat 6A channel, everything passed. We can go in and look at the details of this test if we wish, and we can look at DC resistance. Now, we always run, in that 6 seconds, we're always running the TCL, ELTC, TL, we're running the DC resistance on balance. But you'll notice here they have an informational icon, the little blue circle with the I in it. That means we're just providing it for information purposes, because in this test, I did not specify to use the plus plus parameter and weight those against pass fail. So they're always there, and we can look at them. We can see the unbalance in pair, and we can see the unbalance in pair to pair weighted against the limits. So those are always going to be available to us. So I'm going to go ahead and save this test. And then what I'm going to do is I'm going to change my test parameter. I'm not going to unplug either my main or remote. I'm going to leave my cabling in place. I'm connected to the link here, and I'm going to go back into my test setup and very quickly change my test limit. And this is how you get to that plus plus. I'm going to go back in here. I'm going to go into channel test, and I'm going to go down here, and I'm going to choose this Cat 6A channel plus plus instead of the regular Cat 6A channel. So I've changed that parameter. I can go back through the menus and hit auto test again, or what I'm simply going to do is on my main unit, I'm going to hit the auto test button on the front of the unit, and we're going to go ahead and run this test. And it's still the same 6 seconds, even though we've added these parameters for pass fail, because remember, we're already testing those anyway in the 6 seconds. So in 6 seconds, I now have this plus plus result. And I can see I've got a DC resistance issue. When I first look at this, it's showing me 8.7. My first thought is, well, 25 ohms is my limit, so it's not my loop resistance. It's highlighting in red because one of my resistance parameters has failed, and it's showing me down here I've got an issue of my unbalance in pair. Now I can go to that details screen, and I can go ahead and look at the DC resistance. And we can see our loop resistance is fine. Everything is well below the 25 ohms. I'm going to go over here to the pair to pair. We see our pair to pair looks okay. Everything's below the limit there. But if I go to my in pair, I see I've got an issue with 3, 6, 4, 5, and 7 and 8. So 3 of my 4 pairs have a resistance on balance issue in this case. And this is the same cable that passed the Cat 6A test. But now because I added the DC resistance on balance to my pass fail criteria, it is failing. So I know in this case, I may have some issues with the cabling. I may have to check the patch cords I'm using in my channel test to see if those are the issue, and then troubleshoot from there. So this cable using these patch cords would not support my PoE as I'd like it to. I probably could still run PoE over here, but I may have issues. And what happens is if you have some unbalance issues with your cabling and you're trying to run PoE over it, what can happen is the power needs to be very well balanced going from the source out to the device. If you get some unbalance, what starts to happen is you get some issues with the PSE, you get some issues with the power device, and not just that they're not working, but you can start to see some actual troubles in the PSE. You can start to see your network performance degrade. The cabling can start to heat up. So all kinds of things can start to happen if you have a resistance unbalance issue and you're running PoE, especially at the higher powers where we're starting to see, more than 90 watt PoE running. It's going to be even more evident when you're running something like that. So that's our DC resistance test. And I'm going to go ahead and save this, even though it's a failed test. I'll save it. And then what we'll do is we'll go to our next level of testing here. So this is our DC resistance on balance. And again, it's not a PoE test. So what is a PoE test? So a real PoE test, there's a couple different levels of PoE testing, if we think about it. Some PoE testers are just very basic. They discover PoE and say, yeah, we've got PoE here. It's on these pairs. and it might tell you the level of PoE, might tell you the voltage, and might not tell you the allocated power though. And then other testers will tell you the allocated power, that theoretical number. So beyond that, you've got what's called a PoE load test, and there are several testers out there that can do this. And you can connect to the cabling. You'll do an initial discovery. You see that there's PoE there, and then you demand the load from the switch. So you're seeing, once that load is on the wire, can I actually get that power there? And that's an important part of the test, because just seeing that you have voltage isn't really going to be enough. In many cases. So, we go back to that whole resistance issue, that I squared R equation and everything. What resistance can do, you could take a multimeter and my brother-in-law has a friend, and he was helping her troubleshoot her boat. She had a battery in the boat, and she measured the battery. It was getting correct voltage, but she couldn't get the boat to start. So what happened is they figured out there was high resistance between that starter and the battery. And once you've got that high resistance, you couldn't deliver that voltage to the starter to actually, crank the motor on the boat. So that's just a basic, simple example of what that resistance can do to it. And of course, with PoE, we start to see all kinds of other issues. So that's why that resistance is important. But now we're going to go to a PoE test. So I'm actually going to remove my remote from the equation, because I only need to use the Test Pro main unit for this. And what I'm going to do is I'm going to switch ports on my main. The adapter, don't know if you noticed, the adapters I'm using on here have 2 ports. This functions as a channel adapter in this port, and then the port I'm going to use now is our multi-gig PoE test port, all in the same adapter. So I've connected to my multi-gig PoE port on my main. I'm going to click on multi-gig so I go into the multi-gig mode. And then I'm just going to run this cord down here and plug into a PoE injector that I have coming out of a switch. And then we'll get a connection. And I see I've connected here. So what I'm going to do first is I'm going to look at my PoE. Let's assume I've got a problem. One of my devices isn't working right. I can't get the PoE up. Or maybe I just want to look after I've installed, once my PSE is in, just to make sure I can get that power to the endpoint. So I'm going to click on PoE, and initially it will look and discover the first most important part. Do we have a PSE on the other end of this cable? And yes, we do. What voltage are we getting? Our PSE type, our device class, cable pairs that we're running PoE on, and then of course the allocated power. And you can select, whichever level of PoE you want, whether it's the AT, the AF, or 60 watt UPoE. I'm going to leave it at 90 watt. So now we've got some good information. And again, here's that 71.3 watt number that we've got here. And I'm going to go ahead and click this little lightning bolt. This is our load button. So what I'm doing here is I am demanding the load from the switch. And it's telling me, okay, I can get 66.45 watts over this. And so I've got a little bit of resistance in this cable link. So I am seeing some evidence of that. Additionally, we can decrease or increase our load here and see just how much we can get before we will drop out and not get any load. So I can actually pull a little bit more out of this. And I tried to go too high and it just dropped me to 0. So I could max out on this link at 77 watts. So I should be okay there. So you actually have the ability to do that. So beyond this, you could, and again, this tool will be used for troubleshooting, or it could be used initially after you've installed your cabling and you've got your PSE up and running. But beyond this, you may want to run an additional test. So let's say we have a 10 gig link and we want to provide some as-built information for our customer to show them, yes, we've got PoE at the end of the link. We've got 2.5 gig or 5 gig or whatever it is at the end of the link. And those are good numbers to look at, because a lot of your access points and things like that are going to have a 2.5 or 5 gig link going to them. So what I'm doing right now is I'm running a test. This will take longer than a certification auto test because it's doing a few more things. So what we're doing is we're connecting at 100 meg, 1 gig, 2.5, 5, and 10 gig to make sure first that we can connect at those speeds. And we're also putting traffic on the line. We're measuring the noise on the line at 2.5 gig and above, and we're doing a PoE load test all at the same time. And we can see here we've got our SNR values. That's our noise levels. The higher this number is, the better. And this is user customizable, so you can set whatever that limit needs to be. This is the IEEE bottom end line here, 0.0. Once you get to that number, your noise and your signal are going to be pretty much the same. So you don't want to be down there. So we see we're okay here. We could look at this by pair if we wanted to, assuming that the one of the pair, one of these numbers didn't look good enough to us. We can look and see which pair is the worst case. We see we connected 100 meg and 1 gig, and then we can see our PoE. So we've run that test on the PoE. We've demanded our load. We've got our load at the endpoint, and we can actually save this test just like we would our certification test and allow us to provide this in as-built drawings to our customers. So, we've got this information at hand. We can simply go in and have a project, and then we can go ahead and import our test results. And once my test results come in, I'll pull them up. So here we've got our tests from today. And we can see we've got that one failed certification test right here for the DC resistance unbalance. We've got the test for the multi-gig and PoE, and we've got our past tests. So we can look at any of these tests or generate a report with all of these tests for the customer and show them the test results. You can give them some as-built drawings, not just with the cable certification, but here, as we can see, we have a test showing that PoE level. We see our signal to noise ratio level. So all this can be incorporated into one concise report for the customer. So again, these are things that we would want to look at when we're considering assuring that infrastructure readiness for our smart building systems. So, we're looking at, again, all these different devices that are running over PoE. So, DC resistance unbalance is a very important test for this when you install the cabling. But beyond that, you also need to be able to do some additional things. And being able to have all this built into one tester rather than having to go back and forth between multiple pieces of equipment is pretty convenient. So, so that helps to be able to take your certifier and actually just plug an additional test adapter module into it and run these tests. So I am going to switch back to my camera here, and let me go ahead and see if we've got some questions. And let's look here real quick. For some reason, I'm having problems dragging my screen over. Just give me 1 second, folks. Okay. Yep. Depends on resistance and length of cable. Absolutely correct. DC resistance will be in cable. How can we certify PoE ports of the switch? Okay. Good question here. So from Mohammed Bilal, DC resistance will be of the cable, but how can we certify the PoE ports of the switch? So there's no certification parameter, but what you can do is the test that I just went through, we could actually, if you test out at the endpoint to see what your power level is, and you're seeing a problem, you can go back to the switch and test into the switch port using this same test. So you can find out if you're getting adequate power from the switch port. So that would allow you to do that using that PoE test. So let me see if I can view the rest of these questions real quick. There we go. That's better. So bear with me. Somebody said they couldn't see the screen. Hopefully they could see it. And how can you measure that resistance? Okay, yep, I think we've answered that. Another question from Mohammed Bilal. That would be with that those additional parameters. So again, we run those anyway in the regular Cat 6a test. So you would see those in the test, but you can set it for pass-fail for that as well. So what are the factors? Another question, what are the factors causing resistance unbalance? Having uniform conductor size and insulation. Yes, those will impact it, the conductor size. will impact the resistance. The insulation, not so much, but the conductor size for sure. So certainly if you've got cabling that was manufactured and the quality control was subpar and your individual conductors do not have the exact same diameter, certainly you're going to have a different cable resistance. It would be like having a different wire gauge under the same jacket, and a different wire gauge is going to give you a different resistance. You know, for instance, 12 gauge electrical cable that's used in a typical residence is going to have a much lower resistance value than a 23 gauge Cat 6A cable. The smaller the diameter of that cable, the higher that resistance value is going to be. And that resistance will impede the flow of electrons through the cable. So if you have a manufacturer who didn't maintain their quality in the manufacturing process, and you got individual conductors within that 4-pair cable that were different diameters, then in a sense, they are a different wire gauge and they're going to have a different resistance. Something else that can impact it is as you're pulling the cable in, when you're installing cable, if you exert excessive pulling force when you're installing cable, that can change the resistance. It can increase the resistance of the cable. So you can have some issues there. I mean, if you think about it, you wouldn't see this happen very often, but I was on Chuck Bowser's show. I don't know, I was on his show or he was on my show a while back. I don't remember, but one thing he mentioned was he came across somebody tying the pull rope to the bumper of their F-150 and pulling cable through a conduit. That certainly is going to cause a problem with the cable. And if you think about it, as you stretch that cable out, you're actually changing the geometry of the cable. You can, in fact, change the diameter of an individual conductor if you pull it hard enough, and you will increase that resistance. How can we do full load, i.e. 90-watt testing, continues for a specific time, for example, 30 minutes to verify switch delivering power? So there is a laboratory type test for doing a continuous test like that that involves the use of an external PoE load device. It is geared more toward laboratory than in a field application because when you put an external load on PoE like that, anytime you have an external load, you're essentially putting resistance on there. And to draw that load, you have to generate heat. That's just going to be an impact of it. So what happens is that heat is going to be too intense on that load to actually function as a field instrument. It wouldn't be recommended to do in the field, but it could be done in the lab as well. So is there any maximum efficiency requirements for PoE ports like DOE or COC? Mohammed, I do not know the answer to that question, but I will, we've got it in the comments here. And what I will do is I'll pull some experts. I'll ask some of our engineering team and maybe some other industry professionals and see if we can get somebody to weigh in on that one. And I think we are at the end of our 30 minutes. So I appreciate everybody tuning in today. Hopefully you got something out of today's session, and tune in 2 weeks for the next Tech Talk with Steve. Thank you very much.